if I may, I pleased to introduce our speaker today, Sabin Roman. Is well-known scientist and fellow of the Jožef Stefan Institute in Ljubljana, Slovenia, and a research affiliate at the Centre for the Study of Existential Risk, University of Cambridge. So, Sabin focuses on the developing interdisciplinary tools for modeling complex systems using machine learning. And his research includes mathematical modeling of long-term societal evolution and potential collapse, employing methods like dynamic system theory, network science, and agent-based computing. So today we're going to listen to a very interesting topic, which is a modeling of the collapse of complex societies. Why do societies collapse? And which examples, we will hear about examples and the reason why it happens, and of course about the model, which Sabin will introduce us. So I personally think it's a very interesting topic, and I found it very related to many research of our members and subject of interest of many our members. So please, Sabin.
Thank you for the invitation, and I hope this will be interesting. I've given this talk in various forms, updated forms over the years, and yeah, I'll start a little bit about myself. My background is in theoretical physics, so I come with that type of expertise. I initially did quantum chromodynamics for my master's, and then I changed quite drastically for my PhD. And I did a PhD on this topic of modeling how societies collapse. And yeah, I actually over the years treated basically most cases of collapse that we have significant data for. And here are some of the prominent examples: Easter Island, the classic Maya, the Roman Empire, and the Chinese dynasties. And there is quite a bit to say about each one of them, but I'll try and focus on the commonalities. Yeah, this is so much to say, but I'll try and keep it to the point. So the overall field, you could call it cryodynamics. So cryo is the muse of history. This is a statue of it in Berlin. And there's been a fascinating topic over the last few centuries, but the field is a bit stuck. So it's in a similar state as physics was before Newton. So it was called natural philosophy back then, and it was only much later when it became the mathematical treatment became more sophisticated that it got its name, the present day one. And you can mirror the same situation with historical understanding, list of collapse, that it's very much stuck in this philosophical stage. And you could argue to what extent there's been real progress, because there's endless debates about what constitutes collapse, and there's never any final verdict. Like the same sort of theories tend to get recycled every few decades about what could possibly go wrong. And yeah, there's one particular list for the Roman Empire where over 200 possible causes are listed, and they range from something plausible to something to quite absurd ones. So I won't go into them, but basically every imaginable cause was listed. So as I was saying, mathematical modeling is rare. Data tends to be scarce and sparse. So, and there's apparent intractability, impossible to get beyond the philosophy. And when the mathematics here helps because mathematics adds clarity. once you write down an equation with a clear meaning, it can distill some of the confusion in the topic. So my inspiration, when I initially encountered this sort of land of confusion when it came to theories of collapse and historical dynamics, I went back to physics for inspiration. And the same issue with natural philosophy persisted for most of human history. And the question is, how do we get out of it? And interestingly, the system we first understood and have had predictive power over was not earthbound. It wasn't the weather. It wasn't any geological phenomena. It wasn't fire. It was something at a much larger scale. And it was the solar system. And it's an interesting case why we understood this system first rather than other ones. So when you try to understand physical phenomena on Earth, there tend to be two forces, electromagnetism and gravity. Electromagnetism makes things very complicated because it's responsible for chemistry and all sorts of weather phenomena and so on. So it's very hard to disentangle the effects. However, the moment you go to the scale of the solar system, that no longer counts. So you only really have gravity as a dominant force, and the description actually simplifies. And hence, Kepler could write down his laws. It was a clear enough a sample that you could disentangle this signal, what was the underlying law, and hence predict the trajectory of the planets. So, in a similar way, I wanted to see can we do the same for collapse for societies? So gravity is the dominant force over large spatial scales. So in this case, the solar system. Is there an equivalent of gravity in terms of social forces that persist over long temporal scales? So instead of understanding spatially, we aim to understand temporally in the long term. So collapse is the last thing that happens. So it is characteristic at a largest temporal scale. And for that, we need to find the right force that operates. If there is no such force, and it's just a bunch of random phenomena, then there's no real understanding that you can have. And the endeavor is essentially hopeless. It's just chaotic or whatever else. But from the archaeological record, it seems there are some good candidates for such a force. So this is the first model in the literature. It was done by two economists, and as you can see, it's not a really good fit. The peak of the population isn't adequate. The resource usage is the decline is a bit too mild. Yeah, there's a lot to say about economic modeling. I'm not going to get into it here, but I developed my own model, and this one gives a much better fit. And furthermore, it uses the same parameters as in the economic model. So it's only the structure that is different. And the model I developed is much more ecologically minded. So it's much more plausible respect to the behavior people have in a tribal ancient society, rather than utility maximization or other assumptions about human psychology that have never been validated. So this is the model. I'm not going to go into details. I just wanted to list it, that it's a set of differential equations, and you describe the rate for each stock. And this allows you to basically have a prediction over the long term. This is very much the style of population biology. It's just that you need to add specific terms that have to do with society. So human specific features like capital and wealth accumulation and things of this sort, or infrastructure. So there's another thing that a lot of models in the literature, they don't do a good job in one or more regards. So the most basic requirement is to have a good historical fit. And the model I showed with the economic model will fit for Easter Island. was basically one of the best known in the literature, and yet it's pretty poor. And it fails in the most basic of requirements when it comes to the historical fit. Then there is a plausibility of assumptions. These are also in terms of the rationality and assumption embedded in economic thinking. Again, this is quite problematic. And then there are other elements. It needs to have a meaningful structure, needs to be economical. You need to calibrate it properly. It should be robust. So if you change a parameter, the output shouldn't go haywire. It should also be flexible. So it should have a variety of possible scenarios. And it should be able to extend it if there's new data. Also, obviously, it should be transparent and usable and be able to communicate it clearly and be reproducible. And if you go through every model in the literature, you'll find at least one or probably several of these criteria are not fulfilled. And I made the model for the Maya, and this looks a bit quite formidable, but it's actually fairly simple if you go for the structure in it. And it gives a very good fit. And the way I developed it was keeping in mind all those criteria. And Jožef Tainter, this is the world leading expert on collapse, had some very nice things to say about it in a Nature review paper. So it really matters. The quality of models really matters. Just making a model doesn't mean much. However, if you make a model that satisfies those criteria, has a good historical fit, is plausible, has a good calibration, is robust, flexible, and so on, it's a much more difficult job. And arguably, I think it gets you closer to reality because every one of those criteria gets it closer to reality. However, they're very hard to satisfy. Yeah, I just wanted to point that out because a lot of the conclusion I draw come from the models, and the models are not good, the conclusions are not good. So yeah. Now, insofar as these two cases I shown with Easter Island and the Maya, they tend to have a common feedback mechanism. And this has to do with the working population that extracts resources. So this could be from the forest, the crops, and so on. It derives certain benefits like food, shelter, tools, and various other things that tend to benefit population growth. So, and this sets up a positive feedback mechanism. However, with a larger population, you tend to diminish the benefits faster. Now, I want to generalize this mechanism because it corresponds to a theory by Jožef Tainter, the archaeologist I mentioned before. And this diagram, as it stands, it's somewhat of a generalization of Malthusian theory. But to do that, I need to generalize this a critical concept. So here, the population is specialized and organized at scale, and this gives it a particular property. So that makes it complex. So you can think about complexity in many ways, but for our purposes, it's basically organization and specialization at scale. And here, an orchestra is a good example because it is organized, it's specialized, everyone's playing a different instrument, and it tends to be numerous. And again, the human brain, these are all examples of complex systems. Sometimes complexity gets confused with synchronization. If you have identical components that do the same thing, or they act in synchrony or coordinate very well, because they're homogeneous, they're not complex. So that tends to be confused, like a flock of birds tends to be like one of the examples of a complex system. But then, according to this definition, it's not so much the case. You need this specialization as well. So it needs to be heterogeneous in this way. So one interesting example is with ants. in human societies, distilling the features of complexity can be a bit tricky. We're obviously organized and specialized, but in so many ways that it's hard to pinpoint exactly which of those aspects is most relevant. And the ones that are most relevant have to do with tapping into energy resources. So here you have two ant species. On the left, you have what's called the Myrmicocrypta, and they tend to have very small colonies, up to a few hundred members. They forage only a few meters from their nest, so very low levels of organization necessary, and they are not very differentiated, so only a few types. However, they extract nitrogen from very high quality resources. So this is insect droppings. On the right, you have the Atta ants, which are in the Amazon, and they're very famous, for cutting leaves and making these very long trails. So here the colonies have up to 1 million members, so orders of magnitude larger than the other case. They have to basically forage hundreds of meters from the nest, so this requires very high levels of organization. They have at least 5 different castes, and so they're different specializations, and basically these meet all the features of complexity, and the contrast is very clear. However, the nitrogen source is very poor, which is leaves, and this sets up the fundamental contrast. If you have a simple system, so not very specialized, organized, or big, then it will tend to benefit from very high quality resources. However, if it's complex, large, organized, specialized, then it got that way because it's harvesting very scarce resources, very hard to access. And there's a much more clear example of this. So here you have oil production that illustrates this trend very well for human society. At the beginning of the 20th century, you'd go in the field on a donkey and make a hole in the ground, and you'd have the oil gushing out, and you'd be rich. And yeah, this is like the classic story. However, a few decades later, or like a century, you have something much more like on the right side, where you have to go in the middle of the ocean, dig miles deep, and then risk all sorts of hazards, like the oil rigs exploding. So one is very simple to execute and has a very high return. The other is extremely complex to execute. It comes with a lot of risks, and the return is lower or at most the same. So the net benefit is very much diminished. And this gets me to this diagram. So you have complexity that helps extract resources, that gives you returns, that you invest back into complexity. However, high levels of complexity also comes with costs, and these tend to diminish your returns. So going back to this diagram, the oil industry evolved, it grew in complexity, became more organized, specialized, larger, and it could exploit much more difficult to access resources. However, that also comes with a greater cost. And yeah, the profit margins tend to diminish in energy terms. So I just want to give another example of this diagram because it's not limited to agrarian societies or ecological systems. This is the diagram for the Roman Empire. So the Romans, the main dimension of complexity there was the army. So it's specialized, organized at scale. A large army allows you to conquer more territory. More territory means more taxation, more precious metals, more tribute. That tends to be reinvested in the state and the army. And this sets up this positive feedback mechanism that makes it grow. However, a large army or state also comes with costs, which tend to diminish the returns. So this diagram I found a dynamical system that basically reflects these feedback mechanisms. And if you, how can you sustain the system the moment it reaches like the maximum territorial extent? So what the Romans did was they had very high quality silver coins and they debased them. They added copper. So this expands the monetary supply, allows you to finance the next war. However, if it doesn't work out, you need to do it again. And in the long term, it never worked out. However, their policy was always the same: conquest, expansion, and it worked very well for 500 years. It's just that it didn't work for the next 500. However, it sets up all these institutions and basically social inertia that it's very hard to change. So this is the model output of the model, where you have the territorial extent and the silver content of the coins. I can see it going down. Occasionally, it would spike back up because if they were a bit more successful at some point, and then it will come down. This was essentially their hope that the endeavors would be successful and they could recover, but it didn't happen. And the model also fits the army size, which tends to track the land extent. So once you know this model, you can actually propose also salvation policies, the way you could avoid collapse. So in this case, the optimal policy was to do what they eventually did, which was split the empire into two, east and west. And had they done it 200 years earlier, during the time of Marcus Aurelius, it could have potentially saved the empire. So they have diminished these oscillations and basically prolonged its lifespan until some other factors were at play. Sadly, the brothers of Marcus Aurelius died, Lucius Verus, and yeah, this never happened. But I don't know, a different history for a different time. Now, going back to what I was saying about gravity and social forces that operate over the long term, you can basically zoom out and see different timescales and what effects persist over those timescales. And here you can see over roughly 100,000 years, you have biological evolution, tool making, and climate effects. These tend to be the dominant factors that operate at that timescale. If you go to the 10,000 year timescale, you have the emergence of power hierarchies and agricultural production. So basically, these are two defining features of virtually all societies. All complex societies share these. And people, when they evoke Malthus for the collapse of society, or they invoke inequality for the collapse of societies, they're basically invoking these two features. But these features are universal. So all societies have a degree of inequality because of they have hierarchies inside of them, because otherwise they wouldn't work. And to what extent the hierarchy is dysfunctional and the inequality is unfair, that's usually a symptom of coming collapse. It's not necessarily the catalyzing factor. Same with agricultural production. They're features that are essentially universal, and societies don't have to collapse. They can survive, but that's a more complicated discussion. We can get into it if you're curious. At the 1,000 year time scale, you have this gravity that I mentioned. So these are feedback mechanisms that have to do with this complexity and the resources and returns. And interestingly, there's also religion that tends to be associated with this. So the Romans had Ares, right, the god of war, and it tends to go in parallel with these incentives. Then at 100 years, you have these dynastic policies, infrastructure, demography, and here the work of Peter Turchin tends to be more prominent. This structural demographic theory. And yeah, you can go lower and lower time scales. So economic cycles, political incentives, a decade, and then individual plans are at 1 year timescale. And what's useful about this diagram, about this list, is the long-term forces create a framing or framework for the shorter-term ones. So the short-term forces almost never negate the long-term ones. If they do go counter to them, it's usually when the long-term one ends its cycle. So the temporal bonds become exceeded, and then something new takes its place. So basically, in the case of the Romans, the gravity, these incentives having to do with conquest, they were the common policy for its entire lifespan. And this was something that basically every emperor, everyone agreed upon. And it's the force that tends to persist over time. Everything else, like specific to a particular emperor or king, these tend to fluctuate. And yeah, I mean, if you want to describe that particular time period, it's relevant. But if you want to go between these time periods and find the commonalities, then they're much fewer. So that again, this echoes what I was saying with electromagnetism and gravity. The people tend to confuse these forces quite a bit when it comes to social dynamics. So yeah, that was the core of the presentation. I do have some backup slides, but I guess we can take some questions and see what people are curious about. And yeah, these are basically more articles, including the one in the journal Big History that was published recently. So thank you.
Excellent, Sabin. Thank you very much for this. It's just very fascinating. And, you know, thank you for providing other materials that we can take a look at also. Anton, did you want to handle the questions?
I probably will start with one myself.
You try again. By the way, if you have another request, you don't need to say.
Sorry about that.
Okay. And thank you, Sabin, for very interesting presentation. And my question is about, since I'm very interested in technology, you described very well cyclic nature of civilization dynamics, shorter resources, and feedback loops. Do you think that technological development can be the chain which maintain this evolution, because civilization changes, but progress continues eventually, and regardless of population growth, which we see now, for example, and we've been seeing for a century, and shortage of resources, technological growth continues to progress. What is your opinion on that? Because do you think that technological growth is, first of all, technology is part of your model, and how you describe this connection with your dynamic and technology?
Thank you. Yeah, that's actually my next slide in the backup. Very good. Before I answer, I like to clarify something. It has to do with a certain division of history. And for most of human history, our fastest speed was on foot. So up to the domestication of horses and development of ships, which was around 3,500 BC. We couldn't really, the effective length scale we could reach, like if in a reasonable amount of time, was something like 100 kilometers, more or less, like a few days of travel. And this was characteristic for most of our biological history. And it was only around 4000 BC, 3000 BC, that we developed faster methods. And up to, let's say, 1500, so around 5000 years, this defines what I call the age of seas, because typically next to each big society, you had an associated sea or a certain means of transport that facilitated travel across the empire, like the Mongolians and their horses. So in this case, there's this chunk of history of these 5000 years that is basically, I would say, the canonical testing case. So where it's like the normal chunk of history. Like as characteristic, it's pretty much in a way the same. They have their regional, cultural, whatever variations, but pretty much everyone was doing the same thing, and it's what you'd call a civilization. So what changed was in 1500. So and also the correlation length was something around 1,000 kilometers. So basically, the size of the neighboring sea. So we went from 100 to 1,000. And then in 1500, this changed again. And with Magellan's trip around the world, the correlation length got to 10,000 kilometers, more or less. So events that were quite distant on the planet could influence themselves in shorter and shorter time frames. And this basically means if you want to model a modern society, it has to be, I mean, as a first, it makes sense to model it globally. So like one coherent whole because of this synchronization and over the long distances. So this goes back to technology because that's what facilitates this faster transport. And this is what's special about us, is the fact that this correlation length is the largest it's been in human history. Now, insofar as technology specifically, I had this next slide about what is the main manifestation of complexity in the modern world. And I mean, there might be a few competing answers, but arguably it's technology that is our most significant expression. It's the main paradigm we have when it comes to growth. And then we have a few paradigms when it comes to this, but all our problem-solving endeavors, yeah, so complexity is a problem-solving tool. And we use technology as our first response to any problem. And this makes it the prominent example for complexity in modern society. Now, in our case, we use technology historically to extract energy, and the most prominent form of energy has been fossil fuels. And this obviously improved our lifestyles. So our current lifestyles tend to be comparable to kings of the past. Like, just having ice cream was a luxury for most of human history. So because of this lifestyle, we invest in technology, and the loop goes round and round. However, with technology, you get impacts on lifestyle, and these can be numerous. It varies from pollution to also social degradation, right? Like most of online life, social media, whatever, tends to have a very negative effect on human relationships and psychological well-being. And those are just two examples, of the negative effects. But there'll be a lot more once the fossil fuels tend to diminish. Yeah, so technology is nothing special. It just fits this mold. And it's our particular current obsession, our God, like the closest thing to have to a modern God. And it's not the only one. So the very first one was actually humanism. So placing man at the center of the universe. And this arguably an improvement, right, compared to God. But the Enlightenment would have likely been just in the Renaissance, these would have likely been just like temporary flukes similar to ancient Greece, had it not been for Industrial Revolution, which made technology the highest expression of our creativity and like the solution to all problems. And with technology and expanding material basis, you have economic growth. And when that growth is not adequate, you have debt as a additional mechanism. And once you have collapse, it'll go in the reverse order. Usually you'll have financial debt problems, then economic growth stops, then technology fails. And we're around there at the debt economic growth issues. Technology hasn't failed us yet, but yeah, there's plenty of time. So that's my take on it.
Thank you. So basically, you think that technology even facilitate the collapse?
Just as much as the Romans believed conquest expansion might was the answer, we believe the same about technology. There's no difference. And because it always served us, it never failed us, we believe it'll always be the same until it's not. And even when it's not, we will be in denial of that for hundreds of years until we're over. So there's nothing rational about this. This is why I said it's a religion. There's nothing that can change it.
Interesting. Thank you.
Next.
Yes, are there, oh, okay, Carol?
Hi, this is Abel. We're here. Yes, thank you very much for your presentation. Really appreciate it. And the math is beyond me. So I like to get into the weeds and ask questions about the multiple variables you employ, and you do use multiple variables, recognize that there are 200 causes people list to the decline and fall of the Roman Empire. So I was just wondering, with the Maya, for example, how do you balance the variables that you do take into account, such as population pressures on slash and burn agriculture, the climate change that occurred around that time, increased warfare then being a result, all these things create a polycrisis, as it were. And so I was wondering how you balance them mathematically, what's more important, what's less important, what's more ridiculous. And then I have a quick follow-up to that. Thank you.
Sure. Cool. Yeah, really, does the model hold or not? So that was my confusion when I started. Like it felt like, where do I start? How do I do anything about this? Because it could be anything. So what saved me was the data. So there were some good time series I found that had to do with population growth. So this was the birth rates, the net ones that would also go negative if there was mortality, and the building rates for monuments. So and then what I envisioned was, okay, can I make a simple model that can reproduce both trends? Because both data sets were independent, like they were like 50 years apart or something. The simplest thing I could try was this agrarian model, like resource extraction and so on from the fields, and the soil quality in the Yucatan is not great, actually. So what I used was the best possible parameters, actually. So the parameter, there is a certain parameter in the model that has to do how many times you can harvest before the soil fails. And I used a very large number that was actually characteristic of US soils. And even with the best possible parameters, you still get the collapse. So yeah, and it fits very well with the data. Like there was one remarkable thing. So these differential equations in this, no one is good at them. So the way Feynman said about quantum mechanics, that was overkill. That's way too complicated. We don't even understand nonlinear processes. So there's no, it's very difficult to translate our intuition into mathematics. It's that's why we have mathematicians. And this thing with the modeling, the fact that it worked, I was like, I always see it as like a gift. Like I was just grateful I could stumble upon it, because the chances of finding a model that fits the trajectories and makes sense, and the parameters make sense, and all of these are incredibly slim. So especially if you do it in the wild, right? If you don't necessarily have any systematic method to go through different models. So with AI nowadays, it's a bit more feasible and to some extent. But when I was developing, this was before that. And the fact that it fits so well and it worked, yeah, there's something about that it's hard to convey, but it's hard to convey because the landscape of good models is so poor that it's hard to appreciate if you haven't tried it yourself. So yeah, and even if you use very sophisticated AI, the equation discovery methods that I'm working on now, even then it's very difficult. Like so just stumbling upon the right thing is what Newton said. Like, I'm walking on the shore and I find a pebble from time to time. And it very much feels like that.
Well,
So
this makes, oh, I'm sorry.
yeah, no, that's fine. Yeah, I can go into more detail about the specifics, each one, but yeah, if you have any follow-up.
Well, it's just that this makes perfectly good sense. It falls in line with what Leiter's revealing now, and also qualitatively what Maya historians and archaeologists were always writing about the collapse, and it fits the parameters of soil fertility. My quick follow-up was regarding Rapa Nui or Easter Island. There is an argument out there now, and I'm not an expert, so I reserve judgment here. There is an argument that everything there was always of poor quality, that really there wasn't a collapse, but that people were blown off course, couldn't get back on course. They didn't find Hawaii. They found a place that was less fertile, far less fertile, and they were always eking out an existence that was marginal. So how do you take that into account? Because I know some archaeologists are now arguing that they didn't collapse. They just found a place that was very poor to begin with.
Yeah, so Easter Island it's the smallest case we know of. It probably stirs the most controversy in the field. I'm really very surprised. Like, if you were to look for models and understanding of the Roman Empire, like you have those 200 cases, examples, whatever, that were discussed, but no one bothers with it anymore for some reason. But this little Easter Island thing is just, everyone is obsessed about it for some reason. So for over a century, the understanding on the topic was that you had this essentially ecocide narrative that they overused, and at some point when you have there's this picture Jared Diamond has in his book, that how could they cut down the last tree, right? Like the irony. And the thing is, the moment you have scarcity of resources, you get competition, increased competition. So the different fractions on the island would fragment and compete. And then the question is, who could cut down the trees faster, because they would have a competitive advantage. And that basically solves that paradox. And yeah, the archaeological record is quite full, hundreds of skeletons with marks of violence. So the evidence in that narrative is actually quite strong. And then around mid 2000, 2005 up to 2010, an alternative series of theories came to be. One was like rats, for whatever reason, but I think that got disproven. And then European contact, like they were actually peaceful, nature-loving, kumbaya, all that. And then some nasty people from outside did something that disrupted that paradise. And you should go back to the articles written in response to that. So there's the two authors, Flanley and Bond. There were two that wrote this original a book on Easter Island from the 90s, a book that those two economists ignored because it actually had a time series that they didn't use. And they write counterpoints to this new narrative that it was actually stable. And in the Rapani community of scientists, that it hits hard. Like their critiques to the alternative hypothesis. We have this bias that, oh, it's new data, as that means it's better, right? Like we always do. Like the most recent is the more, I don't know, sophisticated, illuminated, so whatever the technology, right? The more technology means the better answer. Well, not quite. There are certain elements in the way that the data of the new perspective got selected, and there's a lot of gray areas. I don't want to go into it because I don't want to say bad things about people, but it's a very controversial thing, and just the fact that these developments are recent doesn't make them more illuminated. Yeah, there's some very specific articles that I would recommend you read on this one. One is called like Rats and Something Easter Island. I need to send a specific link. It's very sarcastic and really hits home with a lot of points of the debate. They're old. I mean, they were like 2007 something. Like there was some response back then. People don't really care. You have this academia sort of degraded over time. It needs to be flashy, right? It needs to catch your headlines and have citations and whatever. So these have a non-trivial effect on the way science gets popularized and gets attention. And sadly, also the way it's hypothesized, because if you can overturn some well-established theory, you get the spotlight, but doesn't mean the alternative is any good. So these are things that, are important to keep in mind. The purity of science, the sacred, holy thing, is not always there. So
I have more reading to do. I appreciate that answer. I thank you very much.
yeah.
Can I, since we have the mic, I'm just been fascinated with this big history association community that wants to make human behavior into a mathematical model. And I wonder if you could just explain to me, sort of, why do you think that's going to give us answers that are more helpful than understanding evolutionary psychology or genetics or something like that? Why are physicists turning from physics to psychology? This fascinates me. How are you thinking about that?
Well, the thing is, there are not that many, I think, that are doing this. One of few, as far as I know. Peter Turchin is another, and there may be like a bunch of others, but the people that use math of let's say high caliber to tackle these is not an extraordinary number. They're usually people that either do ecology or something, and this collapse can be a side interest, so they have an occasional paper on the topic, but in a dedicated fashion, there are not that many. And in my case, it was a matter of personal interest. Like, okay, I know this stuff in physics. Can I use it for society? The answer could have been no. I mean, there was a whole gamble, basically. The divine inspiration for the models might not have come, and I wouldn't be here. So I just tried, and it worked out. So I got some traction in the answer, but it was not a guarantee. So it was just luck, I would say.
Well, I think it's helpful because I do think some people really are only going to be reached through the language that you speak. I mean, other people, we just finished a book, The Biohistory of Feminism. We're all genetics and psychology, but I think a lot of people will take you more seriously if we're talking about crises and you're in finance or you want to be a billionaire, or I don't know. I think having people who can explain this with models and charts for some human beings, that will have more psychological authority. So that's why I wanted to see you today. I don't know if necessarily you can find more answers than via our route, but I think I was happy you ended up in the same place as we did. I didn't know if that would be true, but I think you can reach an audience that we can't reach. So I hope you continue your work, because although I think both of us blank out when you put on all of your algebra thing, but when you put those charts on and you've done the algebra first, it looks, you're very impressive, and then the charts are very understandable. So I thought it was a marvelous presentation, and we're both going to do a lot of research we wouldn't have. I've been clicking as I go along screenshots so that we can look everything up later. So thank you very much.
Thank you.
Yeah, thank you so much. There is a reason why the math looks impressive. I mean, I'm not sure. I mean, this is very subjective, right? Like, it depends on people's comfort with it. But it does give you an edge in that regards to the mathematics that I said, it adds precision to the concepts, and it gives you possibility for prediction and control. So, like I showed for the Roman Empire, had they had this perspective, they could have intervened. I mean, in principle, intervening involves overcoming many psychological biases, and virtually impossible probably, but in principle, it gives you another lever. You're not left in the the lost land of philosophy, like the natural philosophy, what I was saying. It's very hard to navigate that if you have different possible theories. So there's some slides I actually didn't put, and I regret not doing it. I put one on the main takeaways from the talk. One is the qualitative, which is this diagram, which is the core thing. The second one is the modeling dictionary. So you have all these equations that, for people who know how to use them, it can be valuable, because once you understand a few cases, you can model other cases if they're similar, and that's very valuable. And the third part is the quintessential. So qualitative, quantitative, and quintessential. And the quintessential has to do with the fact that, for example, what influences the trajectory of the society. And you can list dozens of factors, like, I know, natality, religion, war, pandemics, the list can go on. And if you only have, for example, only 14 concepts, depending how you prioritize the importance of each factor, each permutation of those 14 concepts gives you a different theory of society, of history, whatever. And 14 factorial, so the number per permutations, is 87 billion. So that means every person on the planet can have 10 different theories on history and collapse. And basically, try and get any consensus or understanding or action orientation from, 87 billion possibilities. And this is doing the qualitative work essentially means you're stuck in this landscape of, billions, maybe trillions of possibilities. So, and it's essentially intractable. Like, if you don't have data, if you don't have things that anchor it to reality and can validate the perspective, you're lost. Like, some ideas might be popular one time, but a few years later or decades, something else will be popular for whatever reason. So, getting out of that factorial landscape where you have these billions of possibilities, that's the key thing, and that's where the separation of timescales helps, because if you know what factor affects what timescale, you're no longer as confused. You might have a few factors at a certain timescale, and that might give you like a few possible theories, but not that much more. And then if you have also the data and the modeling, you can really pin it down, maybe to a few alternatives. So that's yeah, and yeah, that maybe that's why it feels impressive, because it taps into a very specific part of the landscape that is a bit more yeah, has some bonus points, I guess, for
Well, and I also really like that you're looking at so societies collapsing, because I think we should do a lot more of that. For one reason is I don't see it as a bad thing. Societies collapsing often mean power goes back to women, often mean there's improvement in the environment. I think we need to look at the benefits of the collapse of these materialistic complex societies. I mean, the human race hasn't disappeared. It just, unfortunately, sort of our behavior, we start doing the same thing again. But I like it because the way history, he's a history professor, you know, I'm a social worker. So my thing is what's good for people, for nature, for sentient beings. And I don't think necessarily materialism and money, which is a lot of academia just assumes that it represents intelligence, success, and the height of accomplishment. And so I would really like just more conversations like this, and then maybe we can start looking at, you know, it's good actually sometimes if we simplify things, calm things down. This is not a good thing when the Roman Empire gets that, or the Aztecs, you know, you start having so much wealth, you're torturing people for fun, you don't know what to do with yourself. I mean, collapse can be good, and it's been very good for women. So I don't know how you're going to put them in your model. And thank you for doing ants, because of course they're a female society. So I really like that too.
I didn't tell things about modern society. I hinted at it with technology, but it doesn't look good for us. And if it was only patriarchy, right, that would collapse, that would be okay. But it's a lot more, a lot more that takes a bit too much. So I don't really talk about it, and I'll occasionally include it, but it gets very mixed reactions when I talk about society.
You're saying that, no, I mean, I understand. The way I speak very directly about things is a little shocking. Me being a woman, I can get away with it a little bit more, but no, I mean, the fact of the matter is humans have taken it. I mean, Jane Goodall, before she died, was very frank. I mean, we're not an intelligent species. We're destroying our own home. And that doesn't seem intelligent to me. I think, but yeah, you have to be a little careful about saying it's okay that billions of people could die. That's not okay. It's horrible, but we're responsible for it. And then let's look at, I mean, there's a future for the human race and the planet. We're going to suffer consequences, but I do believe eventually there's going to be a good future. There has been before, right? The Aztecs, modern Mexico is a wonder. So no, we have horrible things we're going to go through that we caused ourselves, and you certainly can't celebrate that. It's horrible to watch it right now, but the planet is strong and human beings are strong. So you can put that in your model somewhere.
Yeah,
In the math somewhere.
Yeah, there's some I can give a very detailed answer in a way with doesn't touch upon modern society too directly, but I just want to see if there's someone else that has any question. If not, then I can answer. I have like, I don't know how many slides, like over 100, maybe 200, and each talk I select which ones work for the audience. And there are a few that have to do with two interesting case studies. One is St. Matthew Island. So this is an island in the North Pacific, off of Alaska, that the U.S. Army used for to put reindeers on. And they wanted to use the reindeer's meat, right, for the outpost there. And they put, I think, 8 reindeers in total initially in 1952 or something like that. And then they would go every few years to check on them. And the population grew rapidly, like from 8 individuals to over 6,000 in the span of like 15 years, something like that, 15, 20 years. So quite exponential. And then a few years later, they checked on them after it reached the peak, and you only had like 40 surviving individuals. And this is the classic case of resource constrained collapse, that there's this rapid expansion. In this case, was strictly biological, and then it hit natural limits, and it declined quite fast. And this would be the case for us when it comes to oil production. So that's the key energy resource we have. And the moment that starts to decline, the production of it, it's a bit more complicated, but that would affect us the most. And it's already affecting us. But there is another type of collapse that is much more dramatic, I think. And this is pretty famous. It depends. Like a few years ago, it was not very well known. Now it might be famous. This Universe 25, the mouse experiment from Khaldun. And there you have all the resources you want, except space. And this normally you just expect the population to grow and reach like a steady state and stay there. This was probably the expectation because it's like the biological norm. However, that didn't happen because of the food availability and lack of predation. The density grew and grew, and the mice actually have a specific way to establish social hierarchy, and they would fight, and whoever won would be the alpha. The problem is because of the small enclosure, whenever the loser would get kicked out from a group, you'd have another coming from another group, and basically they would be constantly fighting. They would never finish this tournament of establishing who is the dominant one. And if that hierarchy of dominance was not established, then they couldn't mate. There was no biological signal for mating. And also because of all the fighting, everyone was very stressed. So the females couldn't even get pregnant. And essentially, this constant competition and fighting traumatized them. And even if you took a mouse out of the environment and put them with normal mice, it couldn't adapt. It was still broken. And this is this is an interesting. The name of the article is very interesting. It's called Death Squared. It's the death of the spirit. And here is a scenario where you have every abundance imaginable, except social roles. There's a limit to them, and once they're filled, if there's too much competition for the available spots, there's never you never settle anything. There's no reproduction actually. So and this might echo a little bit the declining birth rates from everywhere, because there is a constraint, right, on space and economically in many regards regarding the sweet spots in society, and everyone is fighting for them, even men and women, the most basic of distinctions. And if that hierarchy is not stable or established, then there's no going forward. And the problem is, if it goes on for too long and everyone is too affected, we might never be able to, normalize again. So even if we have all the resources, there's no risk. So that's the prospect that I find more disturbing, because for the mice, the trauma translated in this, lack of fertility, whatever. But with us, the high levels of trauma tend to translate to choosing really nasty people in charge, or like defaulting on them. And yeah, like 1930s Germany. So tough times, yeah, don't necessarily make strong people. They can also break them for good. So yeah, that's the prospect I'm more worried about.
Very good. Sabin, if you allow a short question.
Sure.
So you showed us that civilization historically goes through long feedback cycles, growth and decline. There's opinion that globalization could actually break such cycles by creating like a single adaptive global system instead of many independent systems of civilizations and states. What do you think about this?
So and this is a rare type of counterexample that I'll just give from our own lifetime. So when I started this research around 2010, that was like the initial sparks, and I started my PhD in 2013. And I was telling people, oh, the collapse, the whatever. There was the financial crisis, so there was some sensitivity to it. But a few years after that, and I was telling people, they're like, you're insane. Who cares about this? Like, we're going forward and upward, and things are going better and better. And yeah, this was 2010 to 2013 in the UK. So, and basically, yeah, when after I studied my PhD a decade later, and yeah, I would tell people I study societal collapse, and they would all wonder, what's that? Well, what do you mean? And a decade later, and I tell them I study societal collapse, and they just have to look out the window. So it's a very palpable change that if globalization was the almighty power that could shift this, it doesn't seem it worked, at least for the last 15, 20 years. So there is increasing
It's another
tension.
religion, right?
Sorry, what?
Another religion, like.
Well, I'm not sure that the technology does act like a religion. Globalization itself has to do more with trade, like the fact that you have these multinationals and the trade routes and everything that has to be facilitated for just-in-time deliveries and stuff like this. It's related, um, and I think it does operate like a religion as well. It's just more at the corporate, like economic level rather than individual basis. We take it for granted to such an extent that I don't think most people think about it actively. But yeah, it is an endemic thing. The thing is, it tends to increase the interconnection and the complexity. So, and it costs energy. I'm not sure to what extent it produces energy. So, yeah, I mean, I wish that anything modern society produced would be a counterexample to what I described, but nothing has been particularly convincing up to now. Yeah, I hope. I don't want the world to collapse, but it's just nothing particular that stands out to offer that type of hope. Yeah, so I don't know. Well, maybe, but well, that hasn't been looking good lately.
Thank you.
Well, I think this was excellent, Sabine, and it really kind of followed a lot of the topics that we discussed in Big History and brought up a lot of good questions, and obviously have a lot of analysis done out there, and I think we really need to hopefully discuss this more and bring this in, and hopefully we'll keep in touch, and hopefully we can follow your papers as you progress on this, and hopefully we won't have the collapse. But yeah. I know it's hard to hear applause on this, but I think on behalf of everyone here, just wanted to say thank you very much, and it was excellent talk. So before we go, I just wanted to I mean, we can have discussion onwards, but I would like to just share the thing about let me see. share the big history. Again, Journal Big History is where Sabin's paper is. There's a link here. I think you get emails for that. You know, if you're not a member of the IBHA, you can always join it. We also have a feature kind of down below. This is on our bighistory.org page, where if you're not quite ready to join, you can follow the activities and get emails announcing things like new issues of the journal and webinars and symposium and conferences. So just off that main page, just want to have that to be known. And if you have other people that might be interested in following IBHA, please let them know also. And then coming up in early December, so about a month from now, we're going to have a symposium or conference on new big history, theory, methods, objects, and perspectives. I know a lot of you are participating in that and generating papers on that, and the conference abstracts are posted, and we'll have a schedule real soon for that. But that's going to be on Zoom, very similar to this, December 1 through 3, talking about new areas, new directions for big history. So I think I'd just like to open up if there's any questions or comments or any further discussion. But otherwise, I think this was a very nice webinar, and I'll be posting the video, the recorded video, and I hope the AI summary of it. Anything else you would like to talk about or discuss?
I have to get going, sadly. So
Yes, very, very good. We really appreciate you coming, and this was excellent, and we like your paper and the webinar, and it'd be a very interesting research. Very good.
yeah, thank you so much. It was a good chance to. I always take every chance I have to
Excellent.
to present. So
Very
I was
good.
really happy, and very responsive audience. I really enjoyed the questions.
Yes. So if there's nothing else, I think we'd just like to end this webinar. Now, I just really appreciate everyone for coming to this also and participating. And just let me or Anton know about anybody else that you'd like to have to see in the future webinars like this. All right. Very good. Well, thank you very much, everybody.
Thank
See
you
you
so
soon.
much. Thank you.
Take care.
Bye-bye.
Bye-bye.